Okay, guys, welcome. Today we're going to talk about the uses and abuses of percentages. Okay. Now, to start off, we'll start by saying that really, when you think about it, percentages are just an alternative form of fractions, right? The word percent literally means per 100, right? So, for example, if you're thinking of 30%, you really have 30 out of 100, which you could even think of course, as 3 over 10, right? Now, we're going to return to this question a little bit later, but there's several different ways that you might interpret the following statement. If we were to say that the rate of smoking among eighth graders was up 44% to 10.4%, there's sort of two different percentages going on here, right? So we're going to talk a little bit about the differences between the correct and incorrect interpretations when it comes to percentages in this section. Okay, so like we started out by saying, if you have a percent, right, you can think of that in another way by taking p out of 100. And of course, that's what you would do when you convert a percentage to a decimal, right? So if you were to look at 10.4%, you could think of it as converting to a decimal. You would either divide it by 100, or you would move the decimal place over 2 times, and that would give you the 0.104, right? So for example, if we said in that statement that 10.4% of eighth graders smoke, and there are 100,000 eighth graders, then we would take 10.4% of 100,000. And of course, the way that we would do that is we would multiply the decimal version of 10.4%, which would be 0.104, and that would give us 10,400. Right, and just so we're clear, this isn't an accurate statistic as far as I know. This is just, for the sake of the computation. All right, so as an example, if we want to convert a percentage to a common fraction, we just replace the percentage symbol with division by 100, and then we can simplify it. So for example, if I want to convert 25% to a decimal, or to a fraction in this case, I should say, we just replace the percentage sign with division by 100. Right, so 25% literally means 25 out of 100. And of course, you could reduce that if you wanted to 1 over 4. Right, so that would be 25% as a fraction there. Now, if you want to convert a decimal to a percentage, right? So now if you want to be given a decimal number and you want to convert that to a percentage, you would multiply it by 100, right? Or of course, you could think of it as moving the decimal 2 places to the right and then add in the percent symbol, right? So of course, if you have the decimal 0.043, if you want to convert that, you would take 0.43 and multiply by 100, and then that would give you a 43%. Right? Or again, you could have just taken the decimal and moved that 2 spaces over, and you could also get 43% that way as well. Okay. Now, to go from a fraction to a percentage, first what we're going to do is convert the fraction to a decimal, and then we'll convert the decimal to a percentage, right? So we're going to do this example with 1 over 5, right? So now, of course, how do we convert this to a decimal? Now, there's a couple different ways you could do this, right? Now, one way is to write this as a division problem. When you take 1 over 5, you want to do 1 divided by 5, and we'll add some decimals, right? So for example, 5 goes into 1 0 times, so we add the decimal, and we consider how many times is 5 going to 10? Well, it goes in 2 times. So then 2 times 5 is 10, and we get 0, so we know we're done, right? So we know that this is 0.2. And then, of course, from there, we can move the decimal place over 2 spots, and then that would give us 20%. Right? Now, another way that you could have done this, if you're not comfortable with the long division method, is there a way that you can multiply the top and bottom of this fraction so that one of those numbers is 100? Or I should say the bottom number is 100. And of course, you can multiply the top and the bottom by 20, and that will give you 20 over 100, which you can also get 20% that way as well. All right, so those are some basic computations with percentages there. Okay, so let's look at an example. Now, an opinion poll finds that 64% of 1,069 people surveyed said that the president is doing a good job. And let's just make a little disclaimer here that this textbook is not recent, so take this with a grain of salt. But anyway, we want to know how many people said that the president is doing a good job. Well, in this case, we want 64% of 1,069. So how do I do that? Well, I need to convert this to a decimal. So this is 0.64. And then I need to multiply that by 1,069, right? So of course, this is something that we can let the calculator do. If I do 0.64 times 1,069, we get that this is equal to 684.16, right? And in this case, you would probably round down to 684, but if you specifically wanted 64% of 1,069, that would be your exact answer. Okay. Now, the next concept that we're going to talk about that's related to percentages is the idea of absolute versus relative change. All right. Now, regardless of which of absolute or relative change you're looking at, you're always going to have two numbers. You're always going to have a reference value, which I'll sometimes call the old value, and the new value, right? So of course your change, whether it's absolute or relative, will be positive when the new value is bigger than the old value or bigger than the reference value. And of course your change will be negative when the new value is smaller than the reference or the old value. All right. Now, how do you calculate each of these things? The absolute change is the actual numerical increase or decrease from the reference value. So you just find the new value minus the old value. All right, and that gives you your absolute change. Now, the relative change is basically the absolute change, but in comparison to the reference value that you originally used, right? So we'll sometimes even refer to relative change as percentage change, right? And the way that we calculate that is we do new minus the reference, all of that divided by the reference, and then we multiply it by 100 and then attach a percentage on there. All right, so you can think of, again, relative change is commonly even referred to as percentage change because it's a description of how it's changing as a percentage. Okay, so let's look at an example involving that. So now we have that during a 6-month period, Xerox stock doubled in price from 7 to 14. We want to know what was the absolute and the relative changes in the price. Well, the absolute change of course, is the new value minus the old value, or minus the reference value, which in this case, the new value was 14 and the old value was 7. So we get that our absolute change was 7. Now, of course, since this is positive, that means that it's an increase. Right, which makes sense because we started at 7 and we went to 14, and that obviously got bigger. Okay, now for the relative change, we need to do new minus old over old times 100%. And in this case, new is 14, old is 7, over old is still 7, so multiplied by 100%. So this is actually going to give me a 7 over 7 times 100%, which of course is 1 times 100%, which is 100%. Which makes sense because if you double, then you increase by the entire thing that you started with. You made a 100% increase. And again, since it's positive, that means that it's an increase. Okay, let's look at another example. So we have that in 1953, the world population was estimated to be 2.7 billion, and in 2013, it was estimated to be 7.1 billion. All right, so again, let's find each of the absolute and relative change. So absolute, I want new minus old. So that would be a 7.1 billion minus a 2.7 billion. And of course, if we do that, let's see. So if I do a 7.1 minus a 2.7, I should get, what is that? I guess it's a 4.4. So I think we get a 4.4, yeah, billion. And of course, that's our absolute change. Now to get our relative change, I need new minus old over old times 100%. And we found that new minus old in the absolute case was 4.4. And I want to divide that by 2.7 and multiply it by 100%. So if we do that, just let the calculator do the heavy work for us. And we get that this is a 162.96, I'm just going to round to 2 spots here, percent increase, right? Okay. Let's look at another example regarding absolute and relative change. So we bought a computer 3 years ago for $1,000, and today it's worth only $300. So now just be careful here, because now your new minus old isn't necessarily the largest minus the smallest. In fact, in this case, it's the opposite. The new value was 300, and your 1,000 is your reference or your old value. So you're going to have 300 minus 1,000, which is a negative 700. And of course, since this is negative, this is a decrease by 700. Okay, and then for relative, so again, that's new minus old over old. So this is 300 minus 1,000 over 1,000. So it's minus 700 over 1,000 times 100%. And of course, if you do this, this will come out to be, right, if you divide 2 of these zeros with 2 of these, you get negative 7 over 10, which is negative 0.7. So this is a negative 70%. So again, since it's negative, that tells you that you decrease by 70%. Okay. Now, a concept that's very heavily related to absolute and relative change is known to be the relative difference. All right, which is really the same thing, except we're sort of calling our new value almost, we're really just sort of renaming the new value, right? And instead, we're calling it the compared value, right? So the reference value is usually what we compare something to, right? And the reference value usually comes after the word then, right? If we want to know how much more is this than that, the word that comes after then is the reference value, right? And of course, the compared number is the number that's being compared to the reference value, right? So absolute difference, you're really just computing the same way. You're doing the compared value minus the reference value. And again, you're sort of really thinking of this as the new value, right? Minus the reference value, right? And the same calculation will be true for the relative difference. Okay, so let's take a look at an example. So in example 5, we have the average pay for full-time wage earners varies from state to state. Now, recent data in 2009, so not really that recent anymore, but nevertheless, show that New York ranked first in average pay at about $60,300 per person, and South Dakota ranked last at $32,800 per person. Now, we want to compare South Dakota to New York in both absolute and relative terms. Now, since we're comparing South Dakota to New York, we'll think of this as our reference value, and this is our compared value or our new value, right? Usually whichever Thing comes first is your compared value, and whatever thing comes second is your reference value. Right? So in this case, the absolute difference, again, is compared minus reference value. So in this case, we would want to do 32,800 minus 60,300. And of course, if we do that, let's see what we get here. I think we should get a negative 28 something. Negative 28.5 maybe. Negative 27.5, sorry. So we get negative 27,500. So of course that means that in South Dakota, the pay is $27,500 less, right? So the way we can interpret this is that the pay in South Dakota is $27,500 less than New York. All right, and then of course for the relative, that's compared minus reference over reference times 100%. Right, so in this case, we want to do, let me give myself a little bit more room. So we want to do negative 27,500, since that was our compared minus reference, over our reference times 100%. All right, so let's go ahead and do that. So if we calculate this, divided by a 60,300, and we multiply by 100, we're going to get this is a negative 45.605%. Right? So a way that we can interpret this is that we could say, well, the pay in South Dakota is 45.605% less than in New York. And that's sort of the way that we can interpret that one. Okay. So the next thing that I want to sort of comment on is that the difference between when we use the word more than, or the phrase more than, and the phrase of. Now, to sort of see the difference here, we're going to consider a population that triples in size from 200 to 600. Now, if we say that the new population is more than, right, then we say that in regards to percentages that this is 200% more than the original population. Right? And of course, this is a relative change. And if you were to compute this, you'd have 600 minus 200 over 200 times 100%. And that would be a 400 over 200 times 100%. But that's just 2 times 100%. So this is, of course, where the 200% is coming from. So when we use the phrase more than, we're referring to a relative change. Okay. Now, when we say of, right, we're saying that the new population is 300% of the original population, right? So you could say that it's 3 times the size of the original population. So now here, to find this, you're looking at the ratio of the new population to the old population, right? So new population over old population times 100%. So in this case, that's where you would get 600 over 200 times 100%, which would be 3 times 100%, so 300%. Right, that's what we mean by that. Okay, now let's talk about some other phrases that you'll see using percentages. Now, if we say that something is P% more than some reference value, then we say that it's 100 plus P% of the reference value, right? So now we're sort of seeing more than and of sort of coming together in this definition, right? And then just as we can say more than, we can also say less than, and then that translates to 100 minus P% of the reference value. All right, so let's take a look at an example like that. So we have in this example that Carol earns 50% more than William does, okay? And we want to know how many times larger is her income than this, right? So first of all, if Carol earns 50% more than William, that means that if I take Carol and I multiply that by 100 plus 50%, then I will get, wait a minute, I think I have this reversed. Let me erase this. Yeah, this means that if I take William and I raise that by 50%, that will give me Carol, right? Because Carol earns 50% more than William. So I need to make William bigger in order to get to Carol's pay. So this would be that 150%, which would correspond to 1.5 times larger. Right, so that's sort of the idea for that one. Okay, here's a common application. A store is having a 25% off sale. How does an item's sale price compare to its original price? Well, if it's a 25% off sale, that means that it's 25% less than the original price. Right, and of course, how do we say that? That's 100 minus 25%. So it's 75%. Right? And of course, you could relate this by saying that if I take the original item and I multiply it by 0.75, I'm going to get the sale price. All right, so that's sort of how you can use that to find the sale price. Okay, now we'll do a couple of examples of that in a second, but first, I want to also comment on the fact that when you have percentage change occurring to percentage points, you can get percentages of percentages, right? So when you have a change or difference that's expressed in percentage points, that's when you have absolute change, right? Now, if you express the change or the difference with percent sign or the word percent, not percentage point, that's where you have the relative change. So you have to be a little bit careful there. And we'll do a couple of examples of that. So in example 8, we have that the percentage of adults who report reading a daily print newspaper fell from about 78% to 23% in 2013. All right, and we want to describe this change in relative and absolute change. Now in absolute, again, you want to do new minus old. Well, the new was 23% and the old was 78%. Now, if you subtract these, you're going to get a 55%. Of course, negative, right? So this is a decrease in 55 percentage points, right? Because that's how many percentage points that you fell. Now for the relative, right, this is new minus old over old times 100%. So we already found that new minus old was negative 55 and the old was 78%. And then we need to multiply that by 100%. You can really almost think of these percentages as canceling if you want also. All right, but anyway, so now we do negative 55 divided by 78 times 100%. And that will give us that we have a negative 70.5% 70.51%. Now, since this is relative, this is the actual percentage decrease. So to fall from 78 to 23%, this is describing a 70.51% decrease. All right, so you have to be a little bit careful there because you have percentages of percentages going on. Okay. Let's take a look at another example. So in this example, we're assuming that 40% of registered voters in Carson County are Republicans. Okay. Now in part A, we have that the percentages of voters registered as Republicans is 25% higher in Freetown than in Carson City. All right. Now, what percentage of the registered voters in Freetown are Republicans? Now, since it's 25% higher, not percentage points, this is our relative change. Right? So in Freetown, I need to take the Carson City amount and then need to multiply that by 100 plus 25%, since it's 25% more. Now, what was it in Carson City? Well, in Carson City, it's 40%. So I need to take 40% and I need to multiply that by 1.25. Right? And of course, if I do that, that should give me a 50%. So in Freetown, 50% of the registered voters are Republicans. Okay, now let's look at part B. Now in part B, we're wording it the other way. Now it's 25 percentage points higher. Okay, so now in Freetown, this time I'm just taking Carson City and I need to add 25 percentage points to it. So it's 40 plus 25, which is 65%. Since it was discussed in percentage points. So you just have to be a little bit careful there. Okay. Okay. Now, the next thing that we'll talk about is sort of, we're going to come back to the percent more, percent less than, right? So let's consider the statement that if we have retail prices being 25% more than wholesale prices, okay? Now, if we knew the wholesale price, we could find the retail price by taking 125% of the wholesale price, right? And that's sort of what we're going to do here. So for example, if we're given that the wholesale price is $10 and we know that the retail price is 125% or 1.25, then we can find that the retail price is going to be 12.5 or $12.50, right? Because this is my wholesale and this is 125% written as a decimal, right? So that's sort of how we can take this 125% and translating that to an sort of an of statement, okay? Let's look at another example. So you purchase a shirt with a price before tax of $17. The local sales tax rate is 5%. We want to know what is the final cost, okay? So now, of course, how does this work out? Well, you need to take the sale price, and then you need to multiply that by 1 plus the sales tax percent, and then that gets you the final cost. Right, so here the sale price is $17. The sales tax is 5%, so this is a 1 plus 0.05 or 1.05, right? And then that will give us the final cost. So then if we do 17 times 1.05, I think this should be, let's see, we should get a 1785, I want to say, but let's just double check. Yep, so we get 1785. right? So that would be increasing the sale price by 5%. So we want to do 1 plus 5%, or which will ultimately end up being a 1.05. Okay, now here's an interesting problem. Here now we have that the receipt shows that we paid $19.26 for a Blu-ray disc with the tax included. Now, if we know that the local sales tax is 7%, what was the before tax price of the disc? Well, we need to use the same equation that we used before. We want to know that the sale price times 1 plus the tax percent is equal to the final cost. Now here we know the final cost is $19.26. And of course, since the sales tax is 7%, we have a 1.07 here. And then the sale price is what we don't know. So now to get the sale price, now I need to divide both sides by 1.07. So then the sale price is 19.26 divided by 1.07. And of course, if we do that in the calculator, 19.26 divided by 1.07, that will give me that the sale price was $18. All right, so that's our sale price for that. Okay, so now we can return to the question that we talked about at the beginning of the video. Right, so we want to consider the statement where you have the rate of smoking among 8th graders was up 44%, up to 10.4%. So this means that we increased by 44% up to 10.4%. Right, so this is almost sort of worded in the same problem as the last one, right? We have the previous rate, and I need to increase that by 44%. And then that gives me the new rate, the 10.4%. Right, so I should even put that this is the new rate, and this is the increase. Right, so now we have the equation where we have the previous rate times 1.44 equals 10.4. So now, of course, to get the previous rate, we'll divide both sides by 1.44. And we get that the previous rate is whatever 10.4 divided by 1.44 is. So if we do that, we're going to get that the previous rate is 7.22 repeating. So we'll just say 7.22%. Right, so if we increase that by 44%, that will give us the 10.4. All right, so that's sort of the correct way to interpret that. All right, now I want to talk about sort of some misconceptions regarding percentages to close out this video. And that's sort of the ideas where you have people misusing percentages, which can sometimes be on purpose or, of course, sometimes by accident, right? And one thing that we'll see in this example is where you have what are called shifting reference values, right? So let's consider the following. Because of losses by your employer, you agree to take a temporary 10% pay cut, right? So you're going to take a 10% pay cut. Now in 6 months, your boss is going to promise you that you're going to get a 10% raise after 6 months. Now, of course, will this restore the original salary? Right? And of course, the answer is no, but I want to sort of show you a concrete example why. Right? So let's say that you start off with $100, just to have a nice round number. All right? Now, if you take 10% away from that, that means that you're going to take 10 off and you're going to be left with 90. right? Now, if you add 10% to 90, right, you're going to have, 1.1 times 90, and you're going to only come back up to $99, right? So of course, the answer here is no. And that's because in this first point, your reference value is 100, but at this point, your reference value is 90. So even though it seems like you should be getting, if you lose 10% and then get it back, it seems like if you're not clever about it, you might miss that and you might think, oh, okay, well, I'm getting everything back, right? But that's not the case, and that's because of the shifting reference values. Okay. Now, in this next example, we have that a stockbroker offers the following defense to angry investors. I admit that the value of your investments fell 60% during my first year on the job. This year, however, their value has increased by 75%, so now you're 15% ahead, right? And of course, this is also not true, and we'll show this with 1,000 this time, right? So if you start with 1,000 and you take a 60% fall, that means that you're going to be left with 40% or you're going to be left with 400, right? But then if you increase this by 70%, by 75%, sorry, that means that you're taking 400 times 1.75. And if we do that, we're going to end up with, let's just take a minute and calculate it, 400 times 1.75. We're going to only end up with 700. And again, that's because of the shifting reference values. In this one, your reference value is 1,000. And here your reference value is only 400. Right, so that's sort of the issue with that one. Okay. In example 13, we have that a politician promises, if elected, I will cut your taxes by 20% for each of the first 3 years of my term for a total cut of 60%. And of course, this is again not true because of the shifting reference values, but let's do this with 100. So if we decrease by 20%, right, you're down to 80. Now, if you decrease by another 20%, this time you're only taking away $16 instead of $20. So now you're only going to be down to $64. Right? And then if you decrease by 20% again, now you're taking away $12.80. So now you're going to be down to, let's see, so a 51.20, right? Because I'm taking away, let's see, does that make sense? I'm taking away 1280. Yep. Okay, perfect. All right, now if you look at this decrease here, this is only a 48.8% decrease. All right, and again, this is because of shifting reference values. All right, so same idea going on here. Okay. Here's another example that's sort of kind of silly, right? We have that a store advertises that it will take 150% off the price of all merchandise. All right, now what should happen when you go to the counter to buy a $500 item? Well, if you take 150% off, that means that it's 100 minus 150% of $500, right? So you're going to get 500 and then times this minus 50%, right? So this clearly doesn't make sense. Right? Because if it was 100% off, then it would be free, right? So if you're taking an extra 50% off, what should happen is you should be handed, you should be given 50%, right? And that's sort of what's happening with this negative here. If you take 50% of 500, that would be $250. Right, and that's exactly why this is sort of nonsense. So the most that you could decrease an item by would be 100%. Okay, now I believe that this is the last example in this video. Yep. So in baseball, players' batting average represents the percentage of at-bats in which he got a hit. For example, a batting average of .350 means that the player got a hit 35% of the times that he batted. Now, suppose that we have a player batting 200 during the first half of the season and 400 during the second half of the season. Can we conclude that his batting average for the entire season was 300, right, which is the average of the two? Now, of course, the idea here is that this is not true, right? And it does possibly require a little bit of knowledge about baseball to see this, but let's go ahead and let's talk about it, right? So I believe that a baseball season, I believe that it's 162 games. Right, so in each half, there's 81 games. Now, it's possible that in the first 81 games, let's just to make it a nice clean number, that there is 100 at-bats in both. Well, not both. That's what I want to avoid, right? So let's say in the first 81 games, there was only 100 at-bats. And of course, in order to make this true, we need to get 20 hits. And that gets us a .200 average. Right? Now, let's say that in the second half of the season, you got more at-bats. So let's say that there were 400 at-bats. Right? And we want to say that we got a hit 0.40% of the time. So then that should be 160 hits. And this would give us an average of 0.400. Now, of course, if you look at the entire season, there were, if you total these, 180 hits, and there are 500 at-bats. Right? So if we do 180 divided by 500, that's going to give us a 0.360 average. Right? So you have to be careful there that you don't just average those two halves, because in this example, we see that that's not going to work out. All right. So that concludes this video on the uses and abuses of percentages. I hope you enjoyed, and I will see you next time.